Alright folks, this video is going to show you guys a whole bunch of examples that you can do for transmit using the TRX DUO SDR transmitter. First up on the docket here is traditional AM modulation. So we got an audio source. This is going to take the audio, whatever you selected in your PC. It's going to come into the flow graph here, 40 kilohertz. We have an audio filter. 60 kilohertz to 12 kilohertz wide, totally customized. You can make it any bandwidth you want. Then we add one. That's how we get the AM carrier trickery. Then we got to convert it to complex signal. The TRX Duo Red Pitaya as well needs a 50 kilohertz sample rate, so that's why we have this rational resampler to sample the 48 kilohertz to 50 kilohertz. That's what you see here. We use the Osmocom sync. This is the IP address, and we're coming out port 1 of the TRX Duo with the 50 kilohertz sample rate, and we are transmitting at 27 megahertz. Alright, let's go put this on a spectrum analyzer and see what the AM signal sounds like. Alrighty. Let's get the microphone real close. Oh yeah. Oh yeah. So you can see here we got some AM modulation going on, and the signal is real wide, covering about 20 kilohertz of spectrum there at 27 megahertz. Oh yeah. So you can see we're doing AM modulation there, folks. 27 kilohertz of modulation bandwidth. We can narrow that down simply by a couple tippy taps on the keyboard there. There you go. AM modulation at 27 megahertz. West Virginia 5 got down. Alright, next up on the docket, we will still do AM here, but we will do VDigital sideband AM. In that we'll try to have half of our sideband be cut off. This is nothing new. TV signals have been doing this for decades, but just to show you the power here of GNU radio, we can use this complex to complex filter here. Negative 800 hertz to 7 kilohertz will be our modulation bandwidth, and we will then create a VDigital sideband AM signal simply by a few tippy taps in GNU radio, right here. Moonshine radio. Flex radio can't do this. Alright folks, now you're seeing VDigital sideband, as you can see there. Only seeing half the sideband there, kind of interesting. Kind of representing what the TV signals look like there, so very cool, very neat. Beep! Oh yeah, you can hear all that goodness there. We can get real close to the audio there, and you see the signal in the VDigital sideband only doing about half of the bandwidth there because of the complex filtering we're doing here on Moonshine Radio. Complex filtering we're doing here. Real complex filtering we're doing here on Moonshine Radio. Okay, next up on the docket is upper sideband modulation. The flow graph you're looking at here shows you how to do that. Audio coming in, filter it. You can pick the audio filter parameters, whatever you want, by just entering it in the boxes there. Next it goes to Hilbert transform, gets it into a upper sideband signal. We get that stream to a 50 kilohertz rate, and now you will see upper sideband signal with a 12 kilohertz bandwidth at 27 megahertz using the TRX Duo right here on Moonshine Radio. Okay, we have upper sideband now. We have pretty much about 12 kilohertz of bandwidth. Upper sideband modulation right now on 27 megahertz. So hopefully you guys can see that we can pretty much make any signal that you want. That is the power of IQ. When you get things that are locked down like flex radio and all that gibberish, you cannot do any of this. So this is the bleeding edge here. This is upper sideband modulation. We can get the audio real loud now, as you see. Test 1, 2. test 1 2. I think you get the point. You can do upper sideband modulation. Okay, next up on the docket is lower sideband modulation. I've also added a fine frequency tuning that you can do to get the oscillator on this thing exactly at 27 megahertz or whatever else you're trying to transmit. So when you run the flow graph, they'll have a GUI range that you can slop the signal around up and down by plus or minus 1 kilohertz to get that lower sideband signal audio sounding real good. Alright, so now you see the lower sideband signal, and as I slide that GUI around, hopefully you can kind of see I can shift this thing. It's a fine frequency shift, but you can see it does move that around just a bit, just to kind of get the audio wherever you need to go based upon the offset. So nice little tool to ensure that your signal is exactly at the frequency. I'm just simply sliding that slider bar around, so that'll give you something to tune when you're sliding around. Listen to it on your receiver. You just slide that around to the audio sounds real good. Anyway, here it is. Lower sideband modulation, TRX Duo, $200, SDR, IQ, whatever mode and bandwidth you want. Hopefully I've made my point here. Alright, continuing the madness, next up on the docket is independent sideband. So the lower sideband will be the real-time audio source, and the upper sideband will simply be noise, but you can replace that with another audio source, whatever you want to do. But this would be a flow graph of how you could attempt to do independent sideband using the TRX Duo and transmitting on 27 megahertz. Alright, so you see the noise on the upper sideband, and you see the gibberish bouncing up and down. That's the lower sideband of my voice. So just to show you, we can do independent sideband as well. So lots of possibilities when you have IQ modulation. Well, I think we've demoed pretty much the basics here today for what the TRX Duo can do. Clearly we could keep going. We could do narrowband FM, wideband FM, images in the waterfall, you name it. But hopefully this has been a good video for you today to see the power of the TRX Duo SDR. Alright, another thing I will show you is the proof of the Nyquist zone. So here we are running an AM signal coming out at a 27 megahertz carrier. But like I said, this DAC does not have any low pass filter. So the clock in this DAC is 125 megahertz. So 27 plus 125 equals 152 megahertz. So let's go to 152 and see if we see the signal. And indeed we do. So there is the first, or one of the first Nyquist zones of the TRX Duo. So that low pass filter would be probably a good idea. Otherwise this signal would radiate out and you would possibly transmit at 152 megahertz even though you do not want to. So that could be pretty bad if like 152 is a police frequency or something and all of a sudden you come on this frequency. It'd be lower power but still not a good idea. So definitely want to get the low pass filter on the output of this thing. Or if you want to do VHF, you could use these Nyquist zones as I'm showing you here. Again, how did I get 152? It's simply 27 plus the DAC clock, which is 125 megs, and that summation works out to be 152. Well, this is it, folks. I hope you've learned a lot today on what the TRX Duo can do. Thank you much for watching Moonshine Radio. Bye-bye.